Hi guys, how you doing? Hope you're all well. So in this video, we're just going to talk about a recent trip that I just had. I just went away for 2 days during the week for work to Germany, which was really nice. So we went over to my company. It's got a few different international sites in America, a couple in Europe, and a few in Asia as well. Yeah, so we flew out to Germany by myself, and it was an electrical engineering conference, which was pretty cool, really. I mean, it was nice to see all the German engineering, as you can see here, and we just had like a really good, nice sit down. And so we had an agenda with quite a few different points on there. So as you can see here, in terms of power on demand, modeling, safety, IOC, etc. So we had our agenda, and we just sat down, and you've got guys there with 30 years experience in electrical engineering, really clever guys, and it's brilliant to just sit down there. I was the inexperienced person there. Thankfully, I was still able to actually contribute a fair bit as well. But yeah, so it was really good, for me to sit there, take notes, and just learn and listen to, the way that these guys are out there doing things in Europe, in America, in Asia. And yeah, I learned an absolute bunch. So I figured I'd share some of that with you today. Mostly because I don't want to forget these moments. Do you know what I mean? Like, I don't want to be 5 years into my career and be like, there was that time someone spoke about something. So I like to document whatever I do. That way, future me can look back easily and go, wait, when I went to Germany, there was that time I recorded that video doing this, didn't I? So then I can come back and watch this. So hopefully you guys benefit from this kind of video to see what an electrical engineer or controls engineer gets up to. So let's jump in. We'll first start off with, the topics that we went through. So the first topic that they covered was power on demand. So I'm going to try and keep this brief. Power on demand is basically to use the pumps only when you're doing work. An example of that we have in England would be that we have a forging press, which is forging hot bits of metal. That metal needs to come as a hot metal billet. It needs to come out of the furnace. And so what you can do is you can interact with the furnace and know when that furnace is about to release a billet. And then when it's about to release a billet, meaning that the hot metal is now ready to be forged, then you turn on your motors and your pumps and start, and then now you're ready to forge. Another example would be to say, if you're currently forging, but then the operator hasn't touched the joysticks in let's say 30 seconds. So usually the operator will be touching the joystick every 5 seconds, doing some movements or something. Now the press hasn't moved, or the operator hasn't touched the joystick in 30 seconds. You can actually, let's say you got 7 pumps, you can start to ramp down or turn off those pumps, and then once the operator touches the joystick again, you can start to ramp it back up again. So the purpose of all of this is basically to say that you only provide full power to the system when you're doing work. When you're not doing work, then ramp down or even turn off the power. So this has multiple benefits. From them, you save big time on your energy usage. So for the customer, the manufacturing facility, they're reducing the amount of electricity that they're consuming, but also they're saving on maintenance fees because your pump's not running at 100% all the time. You're ramping it down, and so you're going to extend the life of your pump or even your motor as well. So that's kind of the basic understanding of power on demand. But where the conference got technical and kind of went above my pay grade was to talk about torque versus power, and how instead of sizing a motor based upon power, they size it based upon torque. So what's the difference? I mean, torque is the capacity to do work, your ability to be able to do work, and power is how quickly you can do work or how much torque you can provide over a given amount of time. And so again, I'm kind of weak on the hydraulic side. Actually, I'm very weak on the hydraulic side. But they were basically advising us that they now only, when they're sizing up motors for their system, they're sizing it based upon how much torque they want the pumps and motors to be able to have versus how much power they can deliver. And so I think the crux of the conversation around this involved using VSDs or VFDs, so variable speed drives or variable frequency drives, and changing the RPM of the motor so that you could achieve max efficiency on your pump. I believe you adjust your pump stroke or your pump angle. So they use the term pump stroke, but I think pump angle and pump stroke are the same thing. So adjusting your pump angle and pump stroke. So this would be for variable pumps. And again, it's very technical in a sense that, like, so my company are very good at the pumps that they make, and these are variable pumps basically. And so you vary the pump angle, and then you reduce your motor's RPM so that you can get max efficiency, but then also save the customer a ridiculous amount of money in terms of their kilowatt hours. And then also you're working your pump and you're working your motor less as well. So you're increasing the life of your machine, you're reducing maintenance cost, and then you're also saving the customer money on their usage as well. So I think their idea was basically to use this power on demand and sell it to customers as an upgrade to the systems that we've already done. And I think it's honestly a brilliant idea, because I know for a fact, a lot of the systems that we've done across the UK and even in Asia and whatnot, they've got VSDs there, but they might just be being used in a simplistic mode. And so it's kind of almost an easy sell to the customer to be able to say, we don't need to change anything on your system, we just need to adjust the VSD settings, and then we can save you X amount of kilowatts, which would save you 120 grand a year or whatever. With the pump stroke being above 70%, then we're close enough to best efficiency. You don't need to go up to 90%, so you can reduce your RPMs. It gets technical and way above my knowledge. Some other things mentioned here were about when it comes to turning off your motors, it's better to coast your motors till they stop than it is to ramp down, because ramping down produces a high voltage. I think then you need to use like braking resistors and whatnot. So if you can, it's better to dump your pressure and let your motors coast towards stop. And so they did show this example that they had whereby a customer didn't want to switch off their pumps, because there's always the fear that, if you've got it so that your pump is switched off and then your furnace releases a billet, but your pumps are switched off, you might hit that start button and they might not start, and now you've got a hot billet ready to go on your furnace, but you've got no pump ready to do any work. So what they said was, for that customer, they reduced the RPM down from like 1200 or 1500 RPM down to 600 RPM, and just by doing that they saved 25,000 kilowatts per pump. So the next topic they discussed was around 3D modeling, 3D simulations, and in specific a software called Automation Studio. I've never heard of it before, but again, I don't know much about hydraulics, but this software looks amazing. So it's called Automation Studio. The bloody thing is expensive. 20 grand cost up front to purchase it, and then you got to pay 5 grand a year for a license. But the good thing is you can interface it with a PLC and a HMI, so you can actually have your code on a PLC and run it, and you can simulate everything. Now, the simulation argument, or the benefit of simulating, it's something that I love the idea of me doing simulations, but I can't see the benefit in terms of development. Like if you've designed a hydraulic circuit and now you've designed your PLC program, why would you not just commission the machine? Why would you spend ages creating all sorts of, simulations when you can just literally go there in the real world and do it? I'm guessing the real use behind simulating would be for training, so that you could create a simulation of a working system, and then you could train, for example, like service engineers, people that need to go and work on that machine, and be like, look, this is what the machine does. The other benefit, I suppose, would be to explain it to customers, but in my experience thus far, I haven't found many customers that are that interested in technical stuff. They kind of just go, oh, it's too technical for me, I'll leave that to you, just get the thing working. So yeah, there was a decent discussion around this software, and I think the guys, they're going to get together and they're going to make a model for an extrusion press. So I don't really do any aluminium extrusion presses or steel extrusion presses here in the UK, so I'm kind of just leaving that to them. Then we had a discussion around safety. So it was more about how do we go about doing safety on a higher level. So obviously you have the various different manufacturers' safety devices. So you got Siemens and all their F modules. So you got the Safe PLC, Safe Power module, etc., which my company use all of that. But one discussion I found interesting around this, which is worth mentioning, is that my company in Germany, they actually pay an external company to do a risk assessment for all of their jobs. Now, this external company are charging 10 grand, 20 grand for a risk assessment, which I don't know if the UK company on my end makes enough to be able to afford to pay that for a risk assessment. But I mean, they said that, they get in a 80-page, 100-page report on a risk assessment, which it also takes away some blame from the engineering firm, because then now, you know, if an external company who's a specialist in risk assessments has done a risk assessment, and then you followed and carried out the actions in that risk assessment, then you can kind of alleviate some blame from yourself. So that was a kind of nice thing to note. The next discussion we had was around IoT 4. So you've got Industry 4.0, or you've got Internet of Things. But you guys know what I mean. That's basically just connecting your washing machine, your monitor, your TV, your water bottle to the internet. So I found, this is a topic that is very interesting to me. And for example, Arduino are releasing a new PLC soon, should be this month, which will have Wi-Fi. So that's the kind of cool stuff that I like, whereby, you know, if players like Arduino or Raspberry Pi can get into this space and use all of their IoT knowledge to make some improvements, then that's nice. But then there's always the thing where it's like, you're not going to be able to beat a hardwired e-stop, for example. Whenever it comes to safety and really important critical systems that a company can really not afford to go down, they really don't want it on the internet. You know, so I think the IoT space will be good for data collection, data management, for analysis. So I look forward to into getting into that side of things. What I imagine is that you keep a PLC system exactly the same as is. So you have all your pressure transducers and whatever else coming back into your PLC. And then you have some code in your PLC, which is then connecting to a server elsewhere. So that way, if that code fails, or, you know, the server gets hacked elsewhere, it's more like a one-way bit of communication. So the PLC is sending its data that it's collected over to a server, which goes to the cloud. That's how I kind of see Industry 4.0. I can't imagine that, for example, people are going to be starting or doing movements of big machines and whatever over the internet. You know, I can see all of that being an issue. So one thing I know is, for example, with Siemens unified panels, you can access the HMI remotely, but I can't imagine it to be very safe. If you're if someone's able to get onto your network, let's say you got a rogue employee outside with a Wi-Fi password, is able to get onto your network and then just put the IP address of your HMI into his, you know, phone or iPad, have your whole entire HMI, and then just start running pumps and doing, you know, all sorts, having, you know, complete control over your HMI, just like they would if they were physically there. That seems to me to be very risky. But yeah, we'll see where that kind of area of things go. So basically, we just had a discussion around that. It's something that I would say the general consensus was, yeah, it's coming, but in what package, they don't know yet, and we'll kind of see. So I think for my company and the engineers that I spoke to, it's not going to be something that is going to be massive right now. The next discussion we had was around remote access. This is something that I know very well, because pretty much every other week, I'm remoting into a customer site, which I think this is fantastic. So in this sense, you know, you require quite a lot of passwords and whatnot. You've got to be able to tunnel into that person's network. So for example, what we do is we install these net biters that have SIM cards, put that on the panel, and then we're able to connect via that SIM card into that person's PLC, and then we can open up Tier Portal and we can go live on Tier Portal and actually view physically what's happening on that machine and monitor everything, just like as if we was plugged in directly. So this was kind of a basic discussion, and almost everybody agreed that really we should have remote access. The only thing that stops you here is IT companies or IT departments in companies don't want to give you access into their network. So one thing that works well is to just have the machine off the network and then have your own remote access connection in via SIM card, via 4G. The other way is to basically say to the customer, okay, look, plug it into your network, and then, you know, if you need me, so what you do is you leave the network cable, the Ethernet cable, unplugged from it, and if you need me, plug it in, and then phone me and say, look, I've plugged it in, can you log onto the system and have a look? I could do that, and then once I'm done, you can just unplug it physically yourself. Then that way you've got no chance of getting hacked, because the hacker would have to physically come into your site and plug the network cable in and then know all of our passwords and whatnot. So yeah, that's kind of the crux of that conversation. So this is the one that I found really cool. This is a non-hydraulic servos. So basically, our German office, they produce like 1 or 2 of these machines every year. And what the machine does is it basically bolts into, it takes like a connection to various different parts of a car, whether it's like the seat belt, the headrest or whatever. And it just tests to see, will it meet the safety standards? So for example, Porsche, if they've got a new design of a new seat, what they have to do is they have to test that seat to make sure that it's bolted down correctly into the car frame. And then they've got to apply a certain amount of force to that seat, pulling on that force. So as if to say, if someone was driving a Porsche and they hit a barrier, at whatever, I don't know what the safety standard is, but let's say it's 70 miles per hour, that seat must not then go flying through the windscreen, because then if the passenger or the driver's got their seatbelt on, and then they crash, and then that chair goes flying through the window, not it's not very safe. So they need to be able to test to make sure that seat is anchored in. And so this is a seatbelt test stand. It's pretty cool, really. So everything that we do in my company is all hydraulic based, but this is just like the first system that my company have done whereby it's all non-hydraulic, using servos and electronic cylinders. Again, the vast majority of this went over my head, but it was pretty cool to see. And they've been doing it now for like 10 years. So this one that you've seen is the newest one that they're shipping out to Porsche, but they've done one for Mercedes. Obviously they're in Germany, so they've got the whole automotive market there. One thing that was really cool about this system is that it doesn't use a physical PLC. It uses an industrial PC from Siemens, and that runs a soft PLC, so not an actual hardware PLC, but it's called a soft PLC, which is basically software on the IPC. Now what's ridiculous is that this PLC is able to run 1 millisecond cycles, which is incredible. So usually a PLC will run at 5 milliseconds if you've got a very small program, and 10 milliseconds. 20 milliseconds is quite slow. So this is able to run at 1 millisecond cycles. And what it can do is it can record 50 variables each cycle across 20 seconds. A normal PLC would be way too slow to do that. And that's something that we're designing a bridge, and we want to be able to record quite a lot of data. So that's something that we might consider using as well. So yeah, this system machine is quite cool, really. The next thing we discussed was recording data and simulation tools. So this is more of when you're commissioning the system, you want to be able to track a few different variables. So if you're commissioning a press, you might want to look at a variety of different, for example, pressures. You might want to look at the pressure in different cylinders. And so what we have in England is we have some old bit of software when we're running a PC, which takes all of the I/O from the PLC, sends it over into a database. That database is then read on a PC, and then we like hit record, select like maybe 10-12 variables. You can't do much more than that, and then record those variables across maybe 10 seconds, 20 seconds. So that software was written in like 1995. So we use some really old software. The guys in America, they use as well a similar bit of software, but again, very old. And then the guys across Europe, they were using PLC Analyzer and EBA, which are two softwares that are completely separate to my company. So they gave us a bit of a demo across this software. And to be honest, the stuff, these kind of softwares and whatnot are expensive, but it's quite cool. So one of them, EBA, for example, they were able to record 128 variables or 250 variables and log it just all the time. So you just select 250 variables and then you log it. And so what they found was that customers would phone up even after it's been commissioned and say something's just happened. I just was forging and there was this jitter or whatever. And then instead of saying, okay, what would happen with us is we would have to say to them, okay, can you try do that again? And then click the log button. So we didn't have everything automatically recorded. And so whenever someone complains about something, you have to almost kind of trust them. Are they chatting nonsense? Are they not? And then try and get them to replicate the issue whilst you're monitoring it. But what they were able to do with this software is just have it so it's always recorded, always stored away, for whatever, 10 years. And then if the customer phoned and said something's just happened with my machine, you're able to just immediately log on and look at, those 250 variables and say, okay, well, they were doing this, isolate these and have a look to see what happened in terms of the pressure. And you can see, pressure got dumped there for some reason or whatever. So that, again, this kind of tools, PLC Analyzer and EBA, they look very, very fascinating. The one that looked good to me was this expensive bit of hardware. It was called the EBA DAC. And I do remember actually looking at this in university in terms of data acquisition tools. And so this is an EBA DAC hardware PC kind of thing. It connects to your PLC, and the PLC logs all the data to there. That's quite cool. The second to last thing we discussed was network valves. So basically getting valves and connecting them onto the network, which is not something that my company England base has done. But the French guys showed us how they took basic dumb valves, so to speak, and then added Profinet smart valves onto them and used the Profinet smart valves to control the dumb valves. And they were able to then see exactly what the valve was doing, and they could send different waveforms to test the valves. And so it just made maintenance's job a whole lot easier. And so, apparently the customers that they've done it to have all come back and asked for further valves to be upgraded and put onto the network as well. Which to me, as a young engineer, what I want to be able to log on to Tier Portal or whatever, and I want as much hardware on Tier Portal as possible. I expect that I can just right click any device and look at its diagnostic buffer. But the reality is that, most of these valves, if they're not smart, so, you're not able to look at whatever they're doing. So usually we use, for example, electronic pressure controllers so that we can look at the valve's feedback. But having that valve on the network would be so good. So the thing is, again, you always got to weigh up cost of all these things. I know I'm probably not going to be able to get my company to fork out the cost to making all these valves smart. But again, it's something that, costs will come down over time, and I need to keep in mind that, I'd like to get everything on the network. That sounds cool, which might sound like I'm contradicting myself in terms of the IoT thing. What I want is that if I'm in the facility, I can plug my Ethernet cable into the panel and I can see everything. What I think is dangerous is that I can be halfway across the world and I could just with one password log into the system, and not only can I see everything, but I can control everything. And so I think that's where the balance is in terms of, I'd like that if I'm on site, I don't want to have to walk 250 meters to go and move a valve. It'd be great if I could just, have a valve be on the network and I can move it and I can look at its feedback and everything else all from within, whatever. So here the guys in Europe, they used Atos valves and they used the Atos software ZSW, which he said wasn't great to use, but still the customers loved the fact that they could view those valves. So cool. And then on to the last topic, which was HMIs. This is kind of my area in terms of where I feel very comfortable at the moment. I'm very weak in terms of PLC programming, but I'm strong in, I feel like I'm quite strong in HMI. So what was funny was the European guys, they were mostly using Wonderware, which is a Viva InTouch, which to me looks, I look at these systems and I just think to myself, like the other day, as I was leaving Germany, getting on the plane, I saw a Phoenix Contacts HMI for, the bridge part where it connects the plane to the terminal. So that had obviously a HMI for the operator to control. And I looked at that HMI and I went, ugh, that HMI looks ugly. And I took a picture of it. And when I look at Aviva Wonderware, it just looks horrible to me. All of the Siemens WinCC version 7, which I've used a bunch, that looks horrible to me as well. We use it at my workplace and I hate it. But WinCC Unified looks amazing. And to me, definitely the cream of the crop is the Ignition. The Ignition HMIs, they just look absolutely fantastic. And I went through and I showed all of the guys, because I asked them if any of them knew Ignition, and only one of them had used it previously in a different company. So no one in the company has used Ignition yet. And the thing is, it's free to use. It's free to develop. You just have to pay 5,000 when it comes to commissioning. So the fact that you can develop on it for free, and look how clean it looks. It looks absolutely phenomenal. And so, they were blown away by it. I sent everyone links to it. And so I'm going to play around with this quite a lot. I hope to play around with it quite a lot over the coming, weeks and months. I really would like to get good at this Ignition. It looks phenomenal. And to me, this is how you want, like if I was the owner of a manufacturing facility and I bought a new machine in 2022, 2023, I would expect my HMI to look like this. I would expect that the engineers come to me and say, all right, Hamed, the machine's fully commissioned now. And I expect that still sitting at my desk, I'm able to click, open up the HMI on my desk, and I'm able to just see stuff. And again, you know, like I said, in terms of safety, maybe not, maybe I can't control anything from the HMI, but at least be able to see a nice clean HMI like this. So yeah, that's it. That was what we discussed. We discussed, you know, a couple of other things, just a bit like Moog servo valve controllers, these kind of things, but kind of most of it went over my head, if I'm honest. So yeah, and that was the end of my Germany trip. Obviously, I ate a bunch of good food as always. I think one of the most important things is that when you're going away for work, it's that you eat well, and that, you know, if the company's paying for your expenses, you know, why would you be eating McDonald's and KFC? You know, you're just gonna run yourself down. And if I'm at home, I eat well at home. So, you know, when I'm on site or whenever I'm out for work, I try and eat well as well. So not relevant to my Germany trip. But yeah, that was the end of my Germany trip. Hopefully you guys enjoyed the video. If you did, leave a like, and I shall see you in the next one. Take care. Bye bye.